once you understand the principal energy levels, like n equals 1 and n equals 2, n equals 3, and n equals 4, you can start looking at the breakdown of subshells. There are different types of orbitals in an atom. We can have s orbitals, which are spherical. We can have p orbitals, which are peanut shaped, and they have 3 orientations, x, y, and z axis. We have d orbitals, and there's 5 of those, kind of shaped like this. And we have f orbitals, which I can't even attempt to draw, but there's 7 of them. Alright, so now all of these orbitals are not in every level, but there is a pattern. Alright, so here's our n. For our L, things start to split. For n equals 1, we have an L equals 0, which corresponds to S. And so that's 1 orbital, and 2 electrons can fit in every orbital. So that's why there are only 2 electrons in the first energy level. So let's just start labeling this. Orbital diagram, and M sub L, and then M sub S, which is just the spin. And this is basically going to give us our orientations. So each one of these electrons, one of them will have a plus 1/2 spin, and we usually refer to the one pointing up as the positive one, and the one pointing down will have a minus 1/2 spin. So for this electron, we have the quantum numbers n, l, m sub l, and s. It's in the principal energy level of n equals 1. It's in an s orbital, and s is associated with a 0. That's just something you have to memorize. S is 0, p is 1, d is 2, and f is 3. So it's in an s-type orbital. S only has 1 orbital, so its number is 0. And then its spin, for this electron, we would refer to as plus 1/2. Alright, when we go to the next energy level, it splits. We have a 0 and then a 1. So the 0 is an s orbital, so we have 1 orbital in our s, and 1 is p, and p's come in sets of 3s. So we have 3 orbitals with 3 different orientations, and we number them, putting the middle one as 0, and then it's like a number line, -1, 0, and +1. And those are the m sub l's. And our number for our 0, or for our s orbital, would be 0, because there's only 1. And then every time you put an electron in, it will either get plus 1/2 or minus 1/2. So in the second energy level, we can hold 8 electrons. In the first, we hold 2. Alright, then when we get to the third energy level, it splits off into 3 different types of orbitals. And we number them 0, 1, and 2. The 0 is still an s. That s's come in sets of 1. The 1 is a p. They come in sets of 3. 2 is a d, and they come in sets of 5. Alright, so s is always numbered as a 0. P, -1, 0, and 1, and D would be -2, -1, 0, 1, and 2. So let's just say we are talking about an electron in this orbital. Let's do the 4 quantum numbers: N, L, M sub L, and M sub S. Well, it is in N equals 3, the third principal level. It's in a D subshell, and D corresponds to 2. And M sub L is which orientation of the D it's in, and it's in the number 1 orbital, and it's spin up, so we would put +1/2. Now technically we can't see these electrons enough to know which orbital it's in because all these orbitals are equal. But in order for us to all communicate the same way, we number them from left to right and just look at where the electron is and use the same naming and numbering system.